Hello all of committees. We are going to present about acetaldehyde production from ethanol by group flow. The contents include introduction, process description, energy balance and heat exchanger network, economics analysis, and conclusions and recommendations. The first one, introduction. Acetaldehyde is an organic chemical compound which is colorless and flammable liquid with a suffocating smell. It has a wide range of applications such as a food preservative, flavoring agent, and intermediate for producing chemicals such as acetic acid, acetic anhydride. And this table shows the physical properties of acetaldehyde. From the concentration in raw material to produce acetaldehyde, the ethanol market in Thailand is anticipated to face a slowdown in economic growth due to the spread of the COVID-19 pandemic. That is, ethanol production was entering an oversupply state. Thus, the use of ethanol as a precursor to produce acetaldehyde. The reaction to produce acetaldehyde is the non-oxidative dehydrogenation of ethanol as the main reaction shown in equation 1. Nevertheless, the ethanol dehydration, which is side reactions, can be occur as well to produce diethyl ether and ethylene, shown in the equation 2 and 3. The production capacity is approximately to the 31 million pounds per year. The next section is the process description. The production of acetaldehyde in the simulation can be divided into 3 sections. The first one, preparation, dehydrogenation, and the last one is purification. Ethanol steam is fed to the heater E101 for increasing the ethanol temperature to 240 degrees Celsius before flow to the reactor. Ethanol steam after preheating in section 1 and the second steam from section 3 are mixed together before flow through the reactor. The reactor operates at 220 degrees Celsius 10 bars to prevent the occurring of diethyl ether and for simple separation between products and byproducts. After the reaction in reactor, the reactor effluent is compressed by compressor C101 to increasing the pressure before flow through the purification section.
In the purification section, the reactor effluent which was increased pressure by the compressor C101. Then it cooled by the heat exchanger E102, the heat exchanger E103, and the cooler E104, respectively, before entering the fat tank T101 for further separation. The cool reactor effluent what consists of 2 phases, the vapor phase and the liquid phase. In the vapor phase, there are a lot of hydrogen and ethylene, which are byproducts. So we use the fat tank T101 to separate the vapor phase of those byproducts first. Because in the liquid phase, there are still hydrogen and ethylene. After we separating those byproducts by using fat tank T101, so we use the detergent column T102 to eliminate those byproducts. The distillate will be byproduct with a hydrogen and ethylene. The bottom products are water, ethanol, and acetaldehyde. The pressure of the bottom product was reduced by using valve V101. After that, the bottom product from valve V101 was taken into the detergent column T103 to separate acetaldehyde, which is the main product of the process. The distillate is acetaldehyde. The bottom products are water and ethanol. We will bring the bottom product into the valve V102 to reduce the pressure before entering the third distillation column in the next order.
After bottom product stream of distillation column T103, S10 stream relieves pressure through valve. Then stream S11 exchange heat with stream S5 and feed into the distillation column T104 to separate ethanol and water. The purity of ethanol at the top product stream is about 91%. It recycles to the reactor. The bottom product or water is impurity because it contaminates with ethanol. The wastewater is disposed further. Next, we'll talk about energy balance and heat exchanger network. For energy balance in process, we will use the first law of thermodynamics, which is described by conservation of energy. Energy of system can change the form to another form without wasting energy in the system. The change in energy in the system is compared to the difference between the initial and final state of system. So the change in energy in the system is equal to the summation of heat and work. Next, the plan is design heat exchanger network by using pinch analysis. It can recover heat to provide more heat exchange in the system and reduce the utility cost used within the system. Firstly, we will set the T mean value at 10 degrees Celsius. Then composite and gas composite curve is used to find cold and hot pinch temperature, which is 78.3 degrees Celsius and 88.3 degrees Celsius. Then we match streams in process. From heat exchanger network grid diagram, we divide into two parts. There is above pinch and below pinch. First, we tie between process and process stream in above pinch part. Next, we use high pressure steam as a hot utility. From grid diagram, you can see that we use total of 16 exchangers. There are 4 heat exchangers and 12 utility exchangers. Then we use pinch analysis technique to improve the process. We have two areas which are improved in the process. First, preheat ethanol area, and second, condenser of distillation column area, which is around ethanol or steam. For preheat ethanol area, since we want to preheat ethanol to 240 degrees Celsius, for saving energy, we slightly preheat to 240 degrees Celsius before flowing to reactor R101. Therefore, firstly, we change the equipment from heater to heat exchanger because it has sufficient energy to exchange heat. For heat exchanger E101, we exchange heat between S17 as a hot stream and ethanol as a cold stream. Then it has living streams flow out of heat exchanger E101, which are S7, S18 and S1 stream. After that, S1 stream flows to the splitter for splitting flow because S1 has large amount of flow rate causes using a lot of energy to increase temperature to 240 degrees Celsius. So we have to split flow. Flow is split to living stream S3 and S2. For upper stream, it flows to heater E105 to increase temperature from 78 degrees Celsius to 132 degrees Celsius. For heater E105, it used hot utility as high pressure stream for increasing temperature. For downstream, we use heat exchanger to exchange heat between S2 stream and S11 stream. Then downstream S5 and upstream S4 mixes to flow into next preheater. For living stream S6, it is preheated to 240 degrees Celsius by using hot utility as high pressure steam. Then living stream S7 mixes with S25 stream, which is ethanol recycled. After flowing through M102 as a mixer, S8 flows to reactor R101. Next area that we consider is around ethanol R, which is steam out of condenser at distillation column T104. We change to use more amount of air utility since we want to condense ethanol to become more liquid. Next, we can conclude that all process of acetaldehyde in PFD that you can see.
How did about economic analysis? For the equipment cost, was calculated by using M&S cost index. There are 13 units. The purchase and install cost about $10,000 million. For the operating cost, followed by this equation. For the number of operator equation, the number of operator about 14 people. The salary was assumed to be $688 per month. The labor cost is $577 per year. The waste treatment cost is about $814 per year. Total capital of investment is the total cost associated with constructing the plant. There are two types of fixed capital investment, direct and indirect, were shown in this table. For the total fixed capital investment is $36 million. Calculation of manufacturing cost without depreciation followed by distribution. There are 5 variables: fixed capital cost, operating labor cost, utility cost, treatment cost, and the last one is raw material cost. For the utility cost, followed by this table, the total utility cost is $424,000 per year, and the raw material cost is $19,000 per year.
This slide shows the proportional of the total utility cost is $424,385 million per year, have a propane 84%, high pressure steam 7%, and electricity 9%. Working capital cost. The most working capital cost of plant chemical is 10 to 20%. And in this project, working capital is 15% of total capital investment. After calculation, total capital investment is around $43.4 million, and working capital cost is around $6.5 million per year. In this slide, show the information of raw material and production costs. Ethanol used as a raw material in this project. The cost per year of ethanol is around $19 million per year. And in the part of production cost, primary product is acetaldehyde and fuel is the byproduct. The total production cost is approximately by $44 million per year. This table shows the information of direct manufacturing costs, fixed charge, and general expenses. So, total revenue is viewed approximately by
$21 million per year. In the tax rate in this project, we assume that our company is a newly company listed in the stock exchange of the Thailand, so the tax rate is equal to 20%. These cash flow diagrams show the summary of economic analysis in this project. After calculation, interest rate of return is equal to 25% and NPV is equal to approximately by $97.6 million, and payback period in this project is equal to 3.71 years or approximately by 4 years. The potential of this plant can produce acetaldehyde with the capacity is 12,365 metric tons per year, with the operating time 8,404 hours per year. The priority in this process of the acetaldehyde that can produce is 95%. This plant will be located at Rayong Province, Thailand. The interest rate of return is 25% and payback period is 3.71 years or approximately by 4 years. Thank you for your attention.